Welcome to the glassworking shop. Well, progress has been made on the lathe project. In the previous video, I used the lathe with Litton chucks and talked a little bit about how difficult it was to make a scroll chuck. Well, now I've got two of my own scroll chucks made in my shop, and they appear to be working really well. It was a tremendous machining challenge to try to get the parts. I mean, first of all, just to try to figure out how to program the parts, and then second of all, to get them accurate enough to a point where I think they're going to work. So in this video, I'm going to show the current state of progress. Of course, it's far from perfected. There's a lot of work remaining, but so far, I think things are going really well. So let's go over to the lathe and see what's been done. So here's a kind of a close-up of how the scroll chuck came out. Let me rotate around a little bit. I don't know if you can see, but I do have my logo engraved on it. And I have a rather large ring. For those who don't understand glassworking lathes, unlike a metal lathe or a wood lathe that uses a chuck key, a glassworking lathe is loosened or tightened by gripping the ring around the outside. And a small ring gives you less ability to tighten and loosen. The larger the ring, the better the lever action, and the easier it is to tighten or loosen the chuck. Now, you might wonder why anybody would care about tightening or loosening a chuck when you're dealing with glass, because the forces involved are nowhere near the forces that are present on a metal lathe. Why would you care about tightening or loosening? Well, when glass lathe chucks get hot after a long session of doing large work, they get really, really hard to open. And this was one of the challenges that I tried to address in this design, is to figure out how to make it easier to open a stuck glass lathe chuck. Some guys actually have a mallet at their workstation that they beat on the thing to try to get it open. Other times I've seen glassworkers just struggle and struggle and struggle while their piece is getting cold and risking cracking and failure because the chuck is just too hard to open. So another thing different from the last video, I actually managed to anodize the stuff and kind of cleaned it up a little bit and made it a little prettier, including an engraved logo. And so I like things to be pretty and try to put at least a little bit of art into all my designs. The integrated lathe workstation, which I talked about a little in the previous video, is designed to address the concerns, the needs, the work habits of artistic glassblowers. In the scientific world, things kind of went in a different direction. The traditional glass lathe has pretty much no space under the bed, and I thought that having a nice open table under the bed of the lathe would be really, really nice, because glassworkers tend to put work in progress, tear-off rods, tools, who knows what, under the lathe, and it's nice to have a workspace that's under the bed of the lathe. And then another thing, the tradition in scientific glass lathes is to have a mechanism called a fire carriage that's designed to support things like a cradle burner, which is very commonly used in scientific work, but less commonly used in artistic work. So this prototype has no fire carriage. What it has instead is the torch armadillo, which is mounted on a sliding rail. The rail is actually long enough for multiple armadillo-like devices, as well as the possibility of quick change mounts to use different interchangeable torches, and who knows what? It's a work in progress. It's a prototype, and prototypes do tend to evolve. As I showed in the last video, let's see if I can get the image to come up here. I've got the Bunsen's mounted on linear bearings on the bottom rail in a space between the structural members that allows them to move around so that you can grab these little wood handles down in the cool zone where it's nice and cold, instead of the way that a lot of artistic glassworkers use the scientific lathes. They put their Bunsen's up on the fire carriage. They put their Bunsen's in a lot of improvised locations. And as a result of that, they end up having to reach into the area where it's really hot under the hot glass to move things around. And some of them use an insulated glove, and some of them just work as fast as they can and try to avoid overheating their hand. So anyway, this is the current state of the project, the integrated lathe workstation. One of the ideas that I've been trying to do in all of my glassworking stations is to keep the benchtop clean. So I use a steel rolling cart here to put my tools in the water bucket, and got a kind of an improvised manifold for the various different gas hoses. The intention here is to come up with a design where the lathe, the workstation, the auxiliary tool holders, and the entire system is all designed as a system to work together to accomplish the kinds of things that artistic glassworkers need to accomplish. So anyway, today I'm going to do some glasswork on it with the new scroll chucks used for the very first time to actually make glass. So let me get set up and I'll be back in a minute. Okay, time to get started. One of the designs that I'm working on that I think is going to be a great benefit is the microprocessor-based control for the stepper motors. Each axis has its own motor that can be operated in perfect synchronization, or you can introduce twist if twist is necessary. Another thing that the control does, it allows for smooth ramp up and ramp down, so you don't have an abrupt start or stop. So I'm going to do some simple glass work here, nothing really complicated, because it is the first test. Just going to do a little work here on making a thick foot for a hollow object like a heavy goblet or some other kind of object that has no clearly defined use. And I'm going to start off with a piece of 50 by 5 millimeter tubing that's welded onto a 19 millimeter handle. And it's going to start off by closing up the end. Basically what I'm doing here, I'm going to be making a bubble, making a round bottom on the end of the tube, closing up the end of the tube and making a round bottom, and then thickening the glass, kind of building up some thickness, so then later it can be flared out into a thickened disc. Get the torch adjusted here. The alignment of the axes was performed with a dial indicator. There is a bit of adjustment in the position of the axes built in by design, and the alignment was adjusted with a dial indicator, and then I used a fixture that I built that rides on the main rails, and the fixture holds a tool post grinder in position where I was able to grind the steel jaw inserts, and the result is that the chucks are now operating pretty much perfectly on center. Of course, glass isn't perfect, especially this particular run of 50 by 5 tubing seems to be particularly weird in its inconsistency. But that's the world of glass. That's what you get. So I'm kind of tearing off the ratty end here, and so far it feels like a glass lathe. Nothing bizarre, nothing unexpected. Got a blow tube, a blow hose connected to the piece, and so I'm going to be giving it a little puff just to kind of gently start forming a round bottom. I understand that the tradition in scientific glass blowing, a lot of scientific glass blowers, who knows, maybe even most scientific glass blowers prefer hand torches, but I find the bench torch to be really a better option. I don't like holding a heavy hand torch. It makes my hand tired. So I'm trying to look through the glass in order to visualize the wall thickness, which is kind of tricky to do. It's not the world's most straightforward thing to do, and it does require a bit of skill and a bit of practice to do. One strategy that works is just to take the flame away, and as the surface tends to be glowing a lot, and so when I take the flame away, I can more clearly visualize what's going on. And it looks like I have a thick spot right here. Of course, the tubing itself is thin, and the end is a little thinner than I'd like. So I'm going to kind of move the flame over so that I can get a little more thickening at this point and build into the thick spot. For those who are watching this that aren't glass blowers and don't understand a lot of the details that I'm talking about, glass is a very strange material to work with. I've been working with metal for over 60 years and have kind of developed an intuition for how the stuff behaves, particularly when welding. Glass is weird. Cold glass is an insulator, and heat moves very slowly through cold glass, and as the glass heats, its conductivity increases. So hot glass is a much better conductor than cold glass. Also, there's a tendency with new glass workers, with inexperienced glass workers, to think that, oh, the hot spot is where I'm putting my flame. Well, it is after a while. But if you've been applying your flame kind of vigorously and aggressively to one side of the piece, then you move your flame to another side, guess what? The side the flame is hitting is still pretty cold, and the side you moved away from is still really hot. And so you end up getting results that are not the result you expected. So little bit by little bit, I'm trying to build some wall thickness and trying to avoid excessive use of the graphite paddle. It is an important tool, but the more you can do with heat and air pressure, the better you're going to be, because the graphite paddle does leave tool marks. And I'm noticing that there's a bit of crap on the surface of my glass. Maybe this is just a kind of a piece of junk I found in the junk bin. If I was actually wanting to do the highest possible quality work, I probably would have chosen a different piece of glass and maybe cleaned it a little more, but for today's demo, ignore the little bit of scuzz on the surface. When the piece is finished, it'll probably be invisible to most eyeballs unless you're like really used to looking for imperfections in glass. But yeah, little bit by little bit, I'm taking the flame away so that I get a little bit less of the surface glow. And I'm noticing that I have pretty decent wall thickness in the end, consistent up to about this point where it starts tapering off. And thinking that it's almost time to add the support on the other end. And of course the support on the end is not going to just be a throwaway handle. It's going to be the stem that will be attached to the thick foot. So a little puff, and then a word on blowing. You know, people talk about glass blowing, and there's actually very little blowing in glass blowing, and a lot of it is really delicate. So now I'm gonna insert my 19 mil solid rod that will be my thick stem, and then ramp it up to working speed. There's very little blowing in glass blowing, and it's usually pretty gentle. But the question arises, do you blow in the flame or out of the flame? And of course it's a complex topic, and I'm by no means an expert, and I'm sure that the experts disagree among themselves about when to use which technique. If you remove the flame and allow the piece to cool so that the outside becomes somewhat cold and kind of, as we say, frozen, and the inside remains softish, you can end up blowing and getting a really nice clean surface finish, and kind of tend to make the wall thickness a little more uniform. And so some glass workers would say never blow in the flame. Always take the piece out of the flame, wait a couple of beats, let a skin form on the surface, and then blow. But in some cases where you're doing extreme forming, where you want to get the glass really soupy hot, and you know, things like building wall thickness or trying to smooth out imperfections, in some cases a tiny little puff in the flame while the glass is soupy hot actually can produce the desired effect. So what I'm doing now is I'm just welding together the 19 mil rod and the end of my thickened bubble, and just watching to see that the angle where the two pieces meet right there at the point, when I initially apply pressure and squeeze it together, the angle ends up kind of an acute angle, and as the glass starts to flow together, I get more of a fillet. And so I'm really mostly concentrating my heat on the thicker part of the bubble, gently moving the tailstock using the little rack and pinion assembly that is working oh so nicely. The tailstock is sliding on linear bearings, which is it works exceptionally well. Old school glass lathes used plain ways, plain scraped cast iron ways, which it was the tech of the time. It was what they had. It was what machine tools used, and it worked well at the time. But in the modern world, pretty much all machine tools use linear bearings. All modern machine tools use linear bearings. And I think it's the superior approach for a modern glass lathe. So now I've got what appears to be a pretty nice weld. So I'm going to kind of let that stiffen up for a moment. Another thing to be aware of, and this was pointed out to me by one of my teachers, that after doing a fairly aggressive weld where this whole area got really, really hot and really, really soft, it takes a long time for this guy to cool. And even if it appears cold, if I start working out here, what will happen is the inside of the glass will still be soft enough to move while the outside is fairly well frozen and hardened. And so if I apply some forces out here, I'm going to end up producing a kind of a crackle surface on the outside, which is not desirable. So now I'm going to get back to work on the bubble. Now that I've got the end supported here, going to get back to work on the bubble. Of course, as glass gets hotter and looser, it becomes more difficult to work with. It's single-ended, which is why glass workers almost always attach a handle or a punty of some sort to control the glass. If you were trying to work with maybe a 3-inch long piece of very, very hot glass only supported on one end, it'll get out of control pretty quickly. So just kind of concentrating my heat as the process has continued. I have maybe a little bit too thin at the junction point. What appears to be fairly decent wall thickness in the middle, thinning out at the edge, which is kind of close to what I want, because as the foot is moved from a bubble into a disc, I'm going to need more glass right at this point, and of course at this point, to end up with a uniform wall thickness in the result. So I'm just directing the heat right at the thickest point, because that's where I want to start expanding my bubble. And I really do like the mounted torch on the armadillo that allows me to just hold the heat in a position and not get my arm tired and not have the torch bounce around. Okay, getting a little bit now of I have now applied a little bit of air pressure, and I've kind of got the bubble started on its way. It's now looking a lot better at this point, a lot better in the middle, so now I have to turn my attention to this area, realizing that this area is still hot. This is not cold. It looks cold, but it's not cold. So it's part of the timing that you learn when becoming a glassworker, is trying to figure out when to move on from one area to the next area, how much time to allow something to cool before you assume that it's cold and move on. Learning how heat moves through glass really is the hardest part of learning glasswork. And of course, I can't claim to be an expert. I'm still a student, but the more I do it, the more it kind of sort of starts to make sense. So I'm pushing in a little bit with the tailstock, feeding glass into this bubble that I'm developing. And I'm noticing what is easy to get here is a sharp corner right at this point, a sharp inside corner. And I'm kind of working on trying to avoid that, so I'm going to go back to applying heat at the already thickened area, keeping in mind that the area that I just worked on is still retaining quite a lot of heat. Glasswork is slow. And as I've said in my previous videos, this is a kind of a dilemma for teachers and video makers, that there's a tendency to believe that, oh, the audience is getting bored. Nobody wants to watch this in real time, so I'll fast forward, I'll speed it up, I'll edit the thing to make it, to get to the final result a little faster. And that's fine if you're watching for entertainment, but if you're trying to watch it for education and trying to learn how heat moves through glass, well, probably better to do it in real time, even though real time is slow and boring. So I'm kind of getting, still have a bit of a thin section right there, but overall things are going reasonably well. I'm getting a tiny bit off center, which that's also a question that arises when doing this kind of work. If you let it get a little bit off center, pretty soon it's a lot off center. And deciding how much off center you can tolerate before you start to take action is an interesting question. So I'm going to do a little bit of forming here to try to coerce this thing That's looking pretty good. And of course, you know, as I'm describing what I'm doing, keep in mind that I've never made one of these perfect yet. I'm still learning. I'm still a student. Still have my problems. But, as I've said in previous videos, I show what I know. And for a first-time lathe user who's a student of the lathe who's never done this before, yeah, I probably know more than you do. So there is at least a bit of value. What I'm doing now, I'm preparing to cut off the bubble. And I'm using a graphite tool to kind of make a divot here. And then I'm going to start pulling with the tailstock. The graphite tool not only has a mechanical effect of pushing the glass, it also sucks the heat out of that point. So now my hot area is the area after the bubble I want to keep. And as I'm pulling and thinning, let me remove it from the flame a little. Puff, pull, puff, pull, puff, pull. Now I'm thinning the glass in preparation for a flame cut. And here's a trick. When experts, the really best of the best scientific glassworkers do a flame cut, they don't bother letting it cool. They just go right in with the flame, get their timing perfect. Everything is perfect. Everything looks just, they make it look easy. For a less experienced glassworker, a good trick is to do it incrementally. To thin the glass, let it cool, puff, thin, let it cool. Because the goal of what I'm trying to do here is to get a very, very, very thin membrane that just burns away with the flame of the microtorch. So I'm going to put the blow tube in my mouth and stop talking. And there we have a not quite perfect, but certainly usable flame cut. Kind of part of the nature of flame cutting that it always leaves a little blip on the end, and you know, the better glassworkers get a smaller little blip. So now, let's get some fire on this thing. Now I'm going to expand it out. Expand it, turn it into a disc. And what I didn't say just a minute ago, that piece that I tore off, those edges are sharp as razors, and so it's always a good idea to melt off the residue just as a safety precaution in case you happen to reach up and encounter the razor sharp surface. So now, a little bit by little bit. And the tricky part of this process, what makes this a kind of a challenging process, is to try to anticipate in advance how the glass is going to flow, how much glass you need to produce the diameter you're looking for, and how to get a very uniform, thick disc as a result. And of course, I've seen expert glassworkers use a variety of techniques. This is not the only technique, and it might not even be the best, but it's the one that I picked for this demo, so I'm using quite a lot of flame. In fact, actually, for this operation, you could possibly even use a more powerful torch, because this operation likes to get the glass hot. And yeah, keeping it on center at this point is critical. Not too horribly bad. Now I've got a special tool that I cooked up. Just a pair of kitchen tongs with graphite on them. You can also do this with just 2 graphite paddles, but no, I'm a tool maker. I make tools. Be fairly aggressively heating the outside rim while trying to let the inside cool, and I'm applying the torch at the top of the piece and not at the bottom, because if I apply it at the bottom, the heat travels upward and heats the center. What I'm trying to do now is just concentrate the heat on the edge so that I can get a nice sharp cornered edge. So, not perfect, but haven't made a perfect one yet. The chucks do operate smoothly, which I am very happy about. I still have some design work to do. The headstock chuck currently has a electronic brake on it that keeps it from moving when it's turned off, and I like that a lot better. The tailstock is just relying on the holding torque of the stepper motor, which is insufficient, but you know, that's how the world of prototyping goes. And of course, my design philosophy is also part of it, that I typically start small and build up as needed. I under-design first, and then if something turns out to be too small, too floppy, too weak, too wimpy, I add strength, add power as I go. So now my disc has gotten kind of cold, and as I prepare to weld this punty onto the center, I want to reheat my disc so it doesn't explode when I hit it with the flame. Now, when you're doing a flat disc like this, keep in mind that glass expands when it's heated. And if you went to a cold disc and simply applied a large quantity of heat to the center would try to expand against the cold outside rim have nowhere to go and it would explode. So when I let the disc get cold, I'm starting out by applying heat to the rim. Rim doesn't need to get up to working temperature, it just needs to not be cold. And then little bit by little bit, as I move up, getting the disc back up, focusing the heat on the outside rim. And now I'm prepared to weld my punty onto the center without fear that my disc is going to explode. And I'm doing this this is going to be a pretty secure hot seal, fully melted in, because discs can be trouble. These thick discs can be real trouble. Easy to get into trouble making these, and I don't want to have a wimpy seal that falls off. So now, I'll just let that solidify for a moment, and I'm going to return my attention over here. In the process of forming my disc, I ended up with a bit of a bulge right there. Not a problem. Much work remains on this section. I'm now going to be working on getting the stem into the place where I like it. And once again, I can't just immediately go to the area that I want to work. I have to make sure that the whole thing is kind of somewhat uniformly heated before continuing. So now, this is going to be a fairly short little stem. And of course, the stem will be perfected when it's attached to the final piece. And so all I need to do here is get it kind of close enough and ready for the next operation. So this glass rod is also quite scuzzy and dirty, which is fine for the demo, but if this was going to be a really serious piece, I would use cleaner, nicer glass and pay more attention, but for right now, my attention really is mostly focused on how's the lathe working? And the answer is, working great. Feels just like a glass lathe. I have it's exhibiting no bizarre or unexpected behavior. So just little bit by little bit, using my graphite tool to both shape and cool the part that I want to keep, and then eventually it gets separated, and then going with my tear off rod. When tearing off a nipple like that, it's important, and this is something it took me a while to learn when I was starting out, that a good glass worker will subtly move the position of their torch. When you're tearing something like that off, you want it to get nice and liquid so it's easy to pull, but then right at the moment that it tears, you move the flame just a little bit away, because that super, super thin little whisker that is produced when you're tearing off, if you overheat that, you boil the glass and you get a big old bubble. So, going to do a little flame annealing here, getting the piece up to a uniform temperature, because when doing glasswork like this, it's easy to get focused on the work you're doing, on the hot part you're doing, and kind of forget that the part you're not working on is getting cold. And the difference between the hot and the cold is what cracks glass. Borosilicate is a lot more tolerant of temperature variation, and you can get away with a lot more working boro. But still, if you totally fixate, and that's a term that I learned in pilot school about looking at one instrument while neglecting the others. If you totally fixate on the work you're doing and ignore the rest of your piece while it's getting cold, chances are you're going to have a failure. So anyway, that's today's glass piece. Came out fairly nice, not perfect. I haven't done a perfect one yet, but I think it came out okay. Probably as good as any of the ones I do. So, okay, summary and conclusion. The chucks work. Are they perfect? No. Can they be made better? Yeah, probably. But for a first attempt, I think it's a spectacular success. So, anyway, as usual, thank you for watching. It's been fun.